This series of videos is all about helping someone who is used to a beginner method of solving a Rubik's Cube to move to an intermediate method. Welcome, and if you're watching this and have completed the first 2 layers of your cube, then you are only 4 algorithms away from solving it. You can actually get away with learning only 4 algorithms, but it will mean that you'll have to repeat them a few times as you go along. The worst case scenario is that you have to apply these 4 algorithms 11 times. With Look OLL and PLL, however, you can get the 11 down to 4 every time by learning an additional 11 algorithms, making 15 altogether. That might sound like a lot, but if you want to do full OLL and PLL, then you'll have to learn 78 algorithms, so that puts the 15 into perspective. This video is one of the 4 last layer tutorials and deals with First-Look OLL. OLL stands for Orientation of Last Layer, and the goal of OLL is to orient the pieces of the last layer so that there is a solid colour on top. Yellow if you started with a white cross. If you use the most common beginner's method for solving the last layer, then you will find the OLL and PLL methods quite different to what you're used to. However, if you use the Rubiks.com beginner method, then you will be on more familiar territory, and it will be easier to build on what you already know. First-Look OLL makes all 4 edges yellow on top, forming a yellow cross. But unlike the white cross, we don't care about the position of these edges. They don't have to match up with the centres and can be in any position as long as they have yellow on top. So let's make a start. When you have finished solving the first 2 layers, you will have a yellow pattern on the top face. Occasionally you can get lucky and skip this first look step altogether, in which case you move straight to the second look OLL step. Here are some examples with the probability of each one arising. As you can see, the first line of patterns have a single yellow dot. The second line of patterns have an L shape in different orientations. And the third line of patterns have a bar shape, either vertical or horizontal. At this point, ignore any yellow corners, as we are only interested in the edge pieces. If you're a beginner, you might find the yellow corners confusing, but don't worry, you will quickly learn to ignore them and identify the correct case in a millisecond. Before we start, a quick word about cube rotations. You probably did lots of them when solving the first 2 layers, but from here on in, they are mostly unnecessary and should be avoided where possible, as they will slow you down. To line up a pattern correctly, therefore, move the upper layer instead of rotating the cube to the left and the right. You can actually solve this step with just one algorithm, and maybe you know it already from your beginner method. However, you might have to use it up to 3 times. The algorithm is F, U, R, U prime, R prime, F prime. Let's call it FIR-ERF. And if we apply it to the second case with the L shape in the top left corner, then we get a yellow cross and we finish the first look of Look OLL. But while we're looking at this case, let's just see what happens if you do this algorithm to different orientations of the L shape. If we move it to the top right, let's see what happens. We get the same L shape, but note that the corners are different each time. It's the same when you move the L shape to the bottom left. Now you don't need to know this for any reason other than curiosity. However, if you move the L shape to the bottom right, then you always get a dot. This is worth knowing, because now you know how to set one up if you want to practice a dot algorithm, which we'll get to in a moment. So now we'll move to the bar shape. If it is vertical, then twist the upper layer to get it horizontal. If you apply the FIR-ERF now, then you'll get the L shape in the right position. So you just have to do FIR-ERF again to get the yellow cross. Now let's see how to use this algorithm on the dot. Because it's just a dot, it doesn't matter what the orientation of the top layer is. So go right ahead and do a FIR-ERF, and you get a vertical bar. So you need to make it horizontal, and then do FIR-ERF again to get the L shape. Then do FIR-ERF again to get the yellow cross. Now, using a single algorithm multiple times is okay for a beginner. But because we want to move to an intermediate method, we're going to learn another simple algorithm to speed up the bar and the dot shapes. Let's go to the bar shape. Make sure it's horizontal, and then instead of applying for-irf, we use a very similar algorithm. F, R, U, R prime, U prime, F prime. Let's call this fru-ruf. In fact, if you do a fru-ruf after a for-irf, you get back to where you started, because it essentially unwinds it. So here I'm set up for a for-irf, and I have my yellow cross, but if I do a fru-ruf, it goes back to what it was before. While we're on the subject of the bar shape, and we're being curious, let's see what happens if you apply fru-ruf to a vertical bar. Again, it's another way of getting the dot shape. So now we have the dot case in front of us. Let's see how to solve it. Unfortunately, there isn't a nice 6-move algorithm to get from a dot to the yellow cross. So we have to use a combination of the above two algorithms. We can do a for-irf, get the bar horizontal, and then do a fru-ruf. And it's solved. You can do it another way by starting with the fru-ruf instead. That gives you an L shape here, so we need to do U2 and then do our for-irf. And that's the yellow cross solved. So that's all 3 cases done, but it's not quite the end of the story. As you can see, I like to give people options instead of just telling them how I do it. There is a third algorithm that you should at least be aware of, and like the for-irf, it turns an L shape into a yellow cross. This algorithm involves turning the 2 front layers together, known as a wide F, and is denoted as lowercase f clockwise and lowercase f prime anti-clockwise. And the algorithm is actually the same as the fru-ruf above, using wide F turns instead of the standard F turns, so it's easy to remember. To apply this, instead of having the L shape in the top left, we bring it to the bottom right, and we do a wide F, R, U, R prime, U prime, wide F prime. And that solves the yellow cross. Now, the advantages of using this algorithm instead of for-irf are, firstly, you can forget all about for-irf and instead use fru-ruf with the wide F turns by using the L shape in the bottom right. This means that you can use 2 fru-ruf algorithms that are very similar. The second advantage is that for the dot case, you can use the standard fru-ruf and the fru-ruf with a wide F one after each other without having any U-turn in between them. So let's try that. We have our dot and we do our normal fru-ruf, and then we do the wide fru-ruf. And that solves the cross without having a U or a U2 in between the 2 algorithms. So you might wonder why I bothered with for-irf at all. Well, the disadvantage is that some people find the wide F turns a bit clunky and slow. And personally, I don't like using the wide F if I can avoid it, so I'm sticking with for-irf and fru-ruf for now. But of course, the choice is yours. So now you've reached the end of a fairly exhaustive summary of First-Look OLL, a process that will normally take you less than 2 seconds in a solve. When you decide which algorithms you're going to use, practice them a bit, and then check out my second Look OLL tutorial to finish the job.